Welcome to ClickMyProject.com. Let me discuss about the project Joint Image Registration and Diffusion for Panchromatic and Multispectral Images. Let me discuss about the abstract of the project. Proposed an algorithm to fuse the multispectral image with the corresponding panchromatic image using different methods. The multispectral images and their corresponding panchromatic images are collected. Initially, the registration process are performed. For registration process, consider panchromatic image as a reference image and the MS image as the sensed image. The transformation from MS image to pan image represented by estimation of transformation parameters to calculate the transformation parameter by affine transformation model. After that, image fusing of multispectral and pan images are fused. Using iteratively update the objective function. In fusing process, initially construct the objective function. In order to improve the fusion quality, to analyze the fusion quality by estimating the Ergas index with the help of resolution of the high resolution of pan image and low resolution of MS image. When the Ergas index obtains the minimum value, the corresponding transformation parameters are the solution of the joint optimization process. This estimation of objective function performed by iteratively optimization algorithm. Let me discuss about the flow diagram for our process. Initially, the input images has been taken. Here, multispectral image and also panchromatic images are collected. Multispectral image contains many bands. The multispectral images have high spectral resolution. The panchromatic images contains high spatial resolution. When the images are fused, the resulting image contains high spatial and spectral resolution. Next, in the registration. In the registration process, transformation parameter estimation are used for performing registration process. In this registration process, here pan image taken as reference image and MS image taken as sensed image. Based on the least square solution of the affine transformation parameters, the transformation from MS image to pan image are performed. Next, when the matched features are detected from pan and MS images, the transformation parameters are estimated. Next, in the objective function construction. So, objective function fusion process Ergas index estimation. The fusion quality should be optimal when the features of the reference image and the sensed image are matched. Construct an objective function in order to estimate the registration accuracy. Optimization of objective function increase the fusion quality. At the same time, minimize the registration error. Here, Ergas index is used for evaluating the objective function, where the RMSE, that is the difference in spectral information between the ith band of the fused MS image and that of the registered MS image. The lower the value of the Ergas index, the better the global spectral quality of the fused images. When the Ergas index obtains the minimum value, the corresponding transformation parameters are the solution of the joint optimization process. Next, in the iterative optimization algorithm, derive the objective function and estimate the fusion quality by iteratively update the transformation parameters. It is a technique for minimizing an objective function in a multi-dimensional space. First, construct the initial simplex by separating the initial parameter vector along 6 parameter axis based on affine transformation. The objective function value is calculated for every point in a simplex. According to function values, the method iteratively determines a new simplex based on the moment, reflection, expansion and contraction steps. Let me discuss about the random procedure for our process. Select the main function.m file in the current folder, write that file and run for executing this process. And this is the main window of our process. Joint image registration fusion for pan and MS image. Pressing the browse MS image button, you can browse the multispectral image from the dataset folder. Here I am selecting MS image and here I display the band 1, band 2, band 2, band 3, band 4 of our multispectral image, and by pressing the browse pan image button we can browse the pan image from the dataset folder. Now I am selecting pan image. Here panchromatic images are displayed. Pressing the register button we can perform the register operation. Here both multi-band image and also panchromatic images are going to be registered. This process will take some time for executing. Here the pan image are registered, and here it display the result of registered MS image. Next, by pressing the next button, we can move on to the next window of our process. Here the next window are displayed. In this window, image shifting process will be performed. Pressing the image shift button, we perform the shifting operation. Here the shifting of MS pixels into PAN pixels, that is pan pixels. This process will be performed based on the affine transformation model. This will take some time for execution. After completing image shift operation, we can press the next button to move on to next window. This is the output window. Here, by pressing the fusion button, we can perform the fusion operation. Here the both multiband and panchromatic images are got fused. Here I display the output result. This is the PS panchromatic and also panchromatic spectral band result. And this is the pan sharp image, and this is the multispectral image. After that, by pressing the next button, we can move on to the performance analysis window. Pressing the analyze button, we can perform the metric results of our calculation. Here the correlation, Edgar's index, Q-wave, race, RMSE, SAM and SID. Finally, special coefficients are estimated and displayed the values here. In this process, we perform both registration and also fusion operation over our multispectral and also panchromatic images using affine transformation model and also iteratively objective functions. Thank you.